this video is to look for a hidden variable. So what that means is if I'm going to calculate some correlation coefficients. So I'm going to do one for the male absences. So correlation of the male values there, and then comma, and then the year. That's my correlation. And if I do the female absences, and the same thing. So those are my two correlations. The male one is increasing as the years increase. So does the number of male absences. But the female absences has a much different trend. A negative correlation, though it is moderate. And if I also make some scatter plots, so if I do scatter plots for the males, then we'll see why it had such a strong correlation. It's got that trend that is mostly rising as time increases. But you're going to see something interesting when I do the female absences. And I create a scatter plot. There's this weird jump. And so you can see why there was a negative correlation, because the values start higher and then they're lower all of a sudden. But it is a very different jump compared to the male graph. So why is that? So if you do some research, in 1997, maternity leave was included in the absences. So this is what we call a hidden variable. So we can't really compare the male to the female graphs because of that hidden variable. But if I take a moment to delete the data from 1997 and before, so if I delete from 1990 to 1996, then we'll see how that is a more obvious trend, and we'll see how the correlation coefficient is now positive and much stronger and much more comparable to the male. So you have to watch out for those hidden variables. It doesn't mean, we just delete it and ignore them completely, but it gives us any extra research can explain some strange anomalies you might find in the data.